Good day, everyone. Today I'm going to discuss to you about point and confidence interval estimation for population mean. So let's start with what do we mean by estimation? So once we said estimation refers to the process by which one makes inferences about a population based on information obtained from a sample. For instance, I'm going to ask you about the price of a 1 kilo of apple. So you're going to tell me that it will be 80 pesos, 100 pesos. Some will tell me that it ranges from 50 to 100 pesos. So if that will be the case, it implies that the first statement, if you're going to tell me if it is 100, 150, 200, that is what they call point estimation. However, if your answer will be 50 to 100, 80 to 120, then it falls into interval estimation. So once you said point estimation, a point estimate of a parameter is a single value number that can be regarded as a sensible value for parameter. So it implies that if we're dealing with point estimate, there is only single value. However, if we're dealing with interval estimation, it is the use of sample data to calculate an interval of possible values of an unknown population parameter, in contrast to point estimation, which is a single number. So if we're dealing with different range of values, we're dealing with interval estimation. So let us now start with discussing about point estimation. For point estimation, we're going to find the sample mean, sample variance, and sample standard deviation. So for our given problem, find the sample mean, sample standard deviation, and sample variance of the population mean of the following sets of data obtained from random samples. So here are the average grades of grade 11 students in general mathematics. So the first thing that you're going to do, you're going to get the squared of all the values of x. To get the value of squared of the all of x, we're going to multiply the number by itself. So for instance, 78. So automatic, you're going to multiply 78 by 78 and it will be 6,084. 85 times 85 is equal to 7,225. 75 times 75 is equal to 5,625. 83 times 83 is equal to 6,889. 88 times 88 is equal to 7,744. 76 times 76 is equal to 5,776. 82 times 82 is equal to 6,724. 85 times 85 is equal to 7,225. 93 times 93 is equal to 8,649. And 90 times 90 is equal to 8,100. After getting the square root of all the values of x, you're going to add all the values of x to find the value of summation of x. Adding all the values of x, it will be 835. And adding all the values on x squared column, it will be 70,041. After completing all the table, you will only substitute all the values to the given formula. To find the sample mean, you will just simply use x bar is equal to summation of x over n. Our summation of x is 835. So instead of writing summation of x, you're going to write 835. And our n is equal to 10. So by substitution process, it will be 835 over 10. 835 over 10 is equal to 83.5. Now, how about to find the sample variance? To find the sample variance, we will be using s squared. S squared is equal to summation of x squared minus the quantity summation of x squared all over n minus 1. So what are you going to do with this one is to start substituting all the given values. But take note, the notation for sample mean is different from the notation of the population mean. In population mean, we use mu, while for sample mean, we use x bar. For the variance, population variance is sigma squared. However, for sample variance, it is s squared. For population standard deviation, we use sigma, while for sample standard deviation, we use S. Okay, let's go back with the computation part for the sample variance. Let us substitute. So we're going to have 70,041 minus 835 squared over 10 all over 10 minus 1. So you're going to start with simplifying 835 squared all over 10. So you're going to multiply 835 by itself. So 835 times 835 then equals then divided by 10. So it will be 69,722.5. Bring down 70,041 minus the result for 835 squared over 10, which is 69,722.5 all over 10 minus 1, which is equal to 9. 70,041 minus 69,722.5 is equal to 318.5. Dividing this by 9, the answer for sample variance is equal to 35.39. Now, in order for us to find the sample standard deviation, we will just simply get the square root of the variance. So our variance is 35.39. Squaring that, it will result to 5.95. So therefore, our point estimate pertaining for sample mean, sample variance, and sample standard deviation are 83.5, 35.39, and 5.95 consecutively. So now let's proceed with the confidence interval estimation. But before that, let's first have a review about how are we going to use a t-distribution table. Now, to use a t-distribution table, we need the value of the degree of freedom and the alpha. For instance, we have n equals 28 with 90% confidence level. Now, to find df, you will just simply subtract n by 1. So, automatic, we're going to have df is equal to 27. Why is it 27? Because our n is 28 minus 1, that is 27. And to find the given alpha, you will just simply subtract the confidence level by 100. So 100 minus 90, the answer is 10%. So that now we're going to convert 10% by decimal. It will be 0.10. So you're going to use df27. So your df is here, 27, and your alpha 0.10 is here. Now, combining that, you will be able to take a look that the critical t-value is 1.703. So therefore, the answer for this one is 1.703. Now, for number 2, n is equal to 5 with 80% confidence level. So now, to find the df, you will just simply subtract n by 1. So your n is 5 minus 1. So therefore, your degree of freedom is equal to 4. Now, to find the value of alpha, you will just simply subtract the confidence level by 100%. So 100% minus 80%, the answer is 20%. Let's convert 20% into decimal. It will be 0.20. Now, let's take a look the value of t in the t-distribution table. So we're going to use df4 and your alpha, which is 0.20. So we're going to combine that. You will be able to take a look that the critical t-value is 1.533. Okay, now, after that, we're going to have the next example. So it's your time to do this number 3 example. N is equal to 11 with 98% confidence level. So I know you already know the value of the degree of freedom because it's just simply subtracting by 1. So therefore, the degree of freedom is equal to 10. Now, to find the value of alpha, you will just simply subtract 100% to 98% and the answer is 2%. Let's now convert 2% into decimal. It will be 0.02. So let's now take a look on the t-distribution table. It is 0.02 and df which is equal to 10. Now, so therefore, by checking, the critical t-value is 2.764. So this is the critical t-value. So we have 2.764. Now, let's proceed with the number 4 example. N equals 22 with 99% confidence level. So we have df. You already know the df. That's only subtracting 1 to n, which is 21. For your alpha, you will subtract 100% by 99%. That is 1%. Converting that to decimal, it will be 0.01. So let's now write 0.01. So let's now take a look on the t-distribution table, 0.01, and then df, which is equal to 21. So therefore, we're going to have this one, 2.831. So we have 2.831. Now, let's now proceed with the number 5 example. N is equal to 17 with 95% confidence level. So we're going to have df, which is equal to 16, and alpha, which is equal to 0.05. Now, let's look on df16 and alpha, which is 0.05. So therefore, our critical t-value is 2.120. So that's the process on how are you going to find the critical t-value, degree of freedom, and level of significance of the given values. Let us now try this with the given problem. Before we proceed on the given problem pertaining for point and confidence interval estimation for population mean, we should take note of the following. Just always remember that we can use t-value or critical t-value if our n is less than 30 and the sample standard deviation is given. Sample SB, or what we call S, is given. Now, or it's simply sigma is unknown. However, we're going to use C value if n is greater than or equal to 30 and the sigma or population SD is known. So we denote that as sigma. So thus it implies that if sample standard deviation is given or sigma is unknown and n is less than 30, we're going to use t value. However, if the population standard deviation is known, it implies that, and your n is greater than or equal to 30, we're going to use C value. Okay, so, but this is very important, the number of sample. Okay, let's now try an example. Ma'am Amy observed that the mean age of 25 frontliners in Tansa is 23 years with standard deviation of 5 years. What is the point and confidence interval estimate of the population mean when the confidence level is 95%? Also, find the length of confidence interval estimation. Let's start with the first step. The first step for this one is we're going to identify the value of the sample. As you can see on the given problem, we're talking about 25 frontliners. So thus it implies that our n is equal to 25. Since our n is equal to 25, we already know that to find the degree of freedom, we're going to subtract n by 1. So therefore, our degree of freedom is equal to 24. And our sample standard deviation is equal to 5 as can be seen on the given problem. For the second step, we're going to identify the confidence level, level of significance, and critical t-value. As you can see, our confidence level is written on our problem, which is equal to 95%. So the level of significance is equal to 0.05. How did we get the 0.05? We subtract 100% by 95%, and that is equal to 5%. Converting that into decimal, it will be 0.05. Now, how are we going to find the critical t-value? You're going to use the t-distribution table and take a look on the degree of freedom, which is equal to 24, and then alpha, which is equal to 0.05. Then you can now get the value of the critical t-value of the given problem, which is equal to 2.064. The next one is the point estimate. The point estimate is what we call your sample mean. And as you can see on the given problem, the mean age of 25 frontliners is 23 years old. It implies your x bar is equal to 23. So the next step is finding the margin of error. Is equal to positive negative t sub alpha over 2 quantity s over square root of n. Again, this is what we call the margin of error. But what do we mean by alpha over 2? Alpha over 2 implies that we're using the two-tail distribution for t table. Again, alpha over 2 implies that the t-distribution table that we are using pertains for a two-tailed distribution. Now, by substitution process, instead of writing t, we're going to write the value of t, which is equal to 2.064. And then now, instead of writing s, you're going to write 5. And instead of writing n, you're going to write 25. So by substitution process, after the substitution process, you're going to start simplifying this one. So if you're using a simple or calculator, you're going to start dividing this. 5 divided by square root of 25. 5 divided by square root of 25 is equal to 1. So I'm going to rewrite or write the answer here. So, and then bring down 2.064. Just simply copy 2.064 times the answer for 5 divided by square root of 25, which is equal to 1. Multiplying this, 2.064 times 1 is equal to 2.064. So therefore, our margin of error is equal to positive negative 2.064. Take note, positive negative is very important. Now after that, we're going to find the confidence interval estimation by applying this formula. X bar plus minus E. So by substitution process, instead of writing X bar, we're going to write 23. Instead of writing E, we're going to write 2.064. Now we're going to separate positive and negative. So to solve 23 positive negative 2.064. So therefore we're going to have 23 plus 2.064, which is equal to 25.064, and 23 minus 2.064, which is equal to 20.936. Therefore we can say that our confidence interval estimation is equal to 20.936 to 25.064. Now, to find the length of confidence interval estimation, we use the formula LCI, which is equal to 2E. It implies we will just simply multiply 2.064 by 2, which is equal to 4.128. Okay, so let's now have another example. Dr. Altay Nico and Dr. Sean Caris Tuazon have found out that the average weight of 100 COVID-positive patients in Calabarzon selected from a normal distribution is 47 kilo with standard deviation of 7 kilo. Find the point and confidence interval estimate of the weight of the COVID patients using 90% confidence level. Also find the length of the confidence interval estimation. So again, let's start identifying the given values. So our n is equal to 100. As we can see on the problem, we're dealing with 100 COVID positive patients. And our sigma is 7. So why we don't have the degree of freedom? Because we're not dealing with p-value. Like what I told you, since sigma is known, or the population standard deviation is known, and n is greater than or equal to 30, we can say that we don't need to use degree of freedom, and we're going to use c-value. Now, let's now find the confidence level, which is 90%, as can be seen on the problem, and the level of significance is 0.10. Now, to find the critical C value, you're going to take a look on the critical T distribution table on the bottom part, and then you're going to take a look on Z, and then 0.10. And then you will be able to see that the critical C value under 0.10 level of significance is 1.645. Now, for point estimate, we can see that the point estimate is 47, or x bar is equal to 47, because the average weight is 47 kilos. Now, to find the margin of error, we will just simply use the positive negative c sub alpha over 2 times sigma, this is sigma, all over square root of n. So by substitution process, we're going to substitute. Instead of writing c, we will be writing 1.645. Instead of writing sigma, we will be writing 7. And instead of writing n, we're going to write 100. So we're going to divide 7 divided by square root of 100. The answer is 0.7. And then we will just simply copy 1.645. Now, multiplying 1.645 by 0.7, we have positive negative 1.15. Therefore, our margin of error is positive negative 1.15. Now, to find the confidence interval estimation, we're going to have x bar plus minus e. So our x bar is 47 and our e is 1.15. So by substitution process, we will be having 47 plus minus 1.15. Now, what are we going to do? We're going to separate positive and negative. So we're going to have 47 plus 1.15, which is equal to 48.15. And 47 minus 1.15, we have 45.85. So therefore, our confidence interval estimation is 45.85 to 48.15. Now, to find the length of confidence interval, you will just simply substitute the value of E to the formula LCI is equal to 2E. So, instead of writing E, we will be writing 1.15. So, 2 times 1.15, we already know that your length of confidence interval estimation is equal to 2.30. So that's all. Thank you and God bless. I hope you've learned a lot for today's discussion. Please don't forget to like and subscribe on our channel and hit the notification bell button so that you will be updated with our video tutorial. God bless everyone.